All right, we are just going live here, and we're back with another top-down webinar. Today, our topic of the webinar is going to be the top-down oscilloscope. So I'm just waiting for a moment here to make sure all of our live streams are active. So just give me a moment. Okay, looks like we got confirmation. We are live on all of our platforms. So today, like I said, we are going to talk about the top-down oscilloscope. Now, how much we're able to cover is going to be kind of variable depending on how many questions we get, the nature of the questions we get, and of course, the time we have left after we go through what we're trying to accomplish. The good news is, of course, you have the option to put some comments or questions in the live stream, which we are monitoring. And so, if there are specific questions about the scope, we will definitely try to get those answered for you. Now, whether or not we can demonstrate anything that you're asking about on this webinar is variable, but we are definitely interested in the questions you have so that we can try to address those in future webinars. Again, if you're just joining us, we are going to talk a little bit about the top-down oscilloscope today. And the first thing I want to talk about is kind of going through some of the hardware overview. So if you're not familiar, the top-down oscilloscope can be used with a large number of the Pro Series tools. Not all of them, but most of them. So which tools can you use your top-down oscilloscope with? You can use it with the Phoenix Lite 2, the Phoenix Lite 3, the Phoenix Elite, the Phoenix Plus, the Phoenix Plus 2, excuse me, the Phoenix Smart. You can also use it with the Phoenix Max. Those are the tools that we have currently that are supporting the top-down oscilloscope. So you can clearly see that we do have a large variety of options as far as which tools you use it on. Now, I will say personally, my preference is to use it on the Phoenix Max. And of course, this is because the Phoenix Max has the largest screen out of all of the different units that we offer that work with the scope. So the things that you'll see as you use like the Phoenix Lite 3 or 2 is, it's a little bit smaller screen. So being able to see the waveforms on the screen is a little bit more challenging just due to the size of the screen itself. Now, there are also some advantages to using the Phoenix Max with the oscilloscope, and that is one of the reasons would be the shortcut for screenshots on the bottom of the Max. So as we go through this, I'm going to eventually switch over to a live camera showing you the hardware itself, and we're going to also show you just kind of the stuff uh, on the oscilloscope software so you can get a feel for what does it look like, how do we change different parameters, things like that. Because really, you need to know those basics before you try to get a waveform on the screen. And ultimately, that is usually the challenge that new scope users face the most, is understanding how to get the waveform on the screen, right? I know in my many years of using a scope, that was one of the most challenging things that I had to learn was getting the waveform on the screen. All right. So I'm going to attempt to share my screen and we're going to run you through just a couple of different basic tests that we would typically offer or show you how to do on a future webinar with the oscilloscope. Now, we're not going to go through those today on a car. We're not going to try to do those live at this time. But remember, we do these webinars regularly. So if you stay tuned and you subscribe to our channel, we're going to work through many of these tests on live webinars as we go through doing these repeatedly. And of course, they're all going to be recorded, so you will have the option to refer back to them in the future should you need to do so or want to do so. So I'm actually going to change my tack a little bit here, and I'm going to switch cameras first and show you the hardware because I think that that's actually a better idea. So I'm going to switch here. Now you can see I am on my other camera and I've got a couple of scopes next to each other. And you're like, wait a minute, why do you have two scopes? Well, this is an important question that we have to answer before we do anything else, and for good reason. We have two generations of hardware. Now, there is no easy way to tell them apart as far as physical appearance goes. If you hold them up side by side and look at them, you're not going to see any observable differences here. You can see they look identical. If we flip them over and look at them, they look identical. You're not going to be able to tell any difference. Now you're like, wait a minute, so how do I know which version I have? Well, we're going to get to that. we're going to show you exactly how you determine which version of hardware you have by simply connecting them directly to your tool. Now, a couple other minor notes I want to make is one of the simplest things that you can do as far as upgrades go, and you can get these cables from us or at a electronics store, is buying a high quality USB cable with like the gold plated contacts, and also buying one that is longer. If you buy a longer USB cable, you will be able to get your scope farther away from the scan tool, and this is a common thing. Many users like to have the scope either right next to the scan tool because you're using that as your display screen. Other users like to have it really far away because then maybe we don't have to buy as long of scope leads. So just a couple of things there I wanted to mention specifically about the USB cable. Now, as far as connecting it to the scan tool, you're going to plug it into the back of the scope. So here's our scope, and you can see it's a directional plug-in, so pretty easy to see that. So we're going to go ahead and we're going to plug it in, and once you get it seated in there, the app is actually going to launch automatically. Now, I'm going to switch over to the other camera so you can see the Phoenix Max screen. So on the Phoenix Max screen here, we can see the hardware boots up and we've got the scope screen up in front of us. Now, I'm going to go back and I'm going to show you where you can get to the scope software should you connect and not have it boot up immediately, or if you go back out of the scope and you want to go back into the scope without disconnecting and reconnecting. If we hit the module button in the top right corner here, you're going to see the oscilloscope tab actually lights up in red. This means that the tool is recognizing that the oscilloscope is connected, so we can tap on oscilloscope and get right back into the software. One version of the hardware, you will likely get a launch screen that looks like this with the white background. Sometimes you will get a different background, and that usually means you have a different version of the hardware. Now, again, there's two different versions of the hardware. The overall functionality is virtually identical, so don't get too confused on that. Um, what we're going to show you is a lot of the basic controls. And again, it doesn't matter really which scope we're using here between the two hardware versions. Just understand that the buttons will be in a little bit different spot on the screen. So as we look on the screen, there are a number of common things that as you learn how to use a scope, you're going to want to know where they are located. Number one, where are most of our settings? So in the top left corner, you're going to see a menu button. And there are a bunch of different settings in here, and we are not going to go through every one of these today, but we're going to show you just some of them and what they might be for, right? So the first thing I like to show people is the user set section. So in the user set section, we have not only our sample rate, which is listed as depth. So the terminology is a little weird, but depth is your sample rate. Now this particular scope has a fixed sample rate in ranges. So what does that mean? When you have a faster signal, like a CAN bus signal, you want to use that maximum sample rate. When you are looking at something that is a slower signal, and or you want to cut out some of the signal noise that you will naturally get when you connect to various things, you want to turn your sample rate down to one of the lower ranges. Now, this is something you can change on the fly, which will allow you to kind of see how it affects the waveform. And again, this is a really easy way that you can cut down signal noise and get a clearer or cleaner looking waveform when you are trying to make a capture. So that's where sample rate is found. Now we also have a few other things here. We have our factory reset button. This is a super duper easy way that you can use if you are trying to essentially bring the scope back to a baseline where none of the settings are set up in a specific way. Again, if you're just joining us, we're talking through some of the basics of the setup on the top-down oscilloscope, and we're going to show you just a variety of different things that you need to know in order to be able to use the tool effectively. So that factory reset will basically make the tool reset all the settings on the scope back to a baseline. And that is helpful if you've been using it specifically for something specific and you want to get all the way back into, let's say, for instance, kind of just, hey, nothing has been changed, nothing has been modified. This is how it is when it first boots up, when nothing has been set up. So that factory reset button can be very helpful. Again, that's in Menu, User Set, Factory Reset. Now, the other one that's in this particular menu under Menu, User Set is Self Adjust. Now, the Self Adjust function is something you should perform on a semi regular basis. If you're able, I'd recommend do it at least once a day. Now, what does it do? What it does is it baselines all of the channels on the scope and it zeroes them out properly. So it's going to make sure that there's no issues with the zero setting on each of the individual channels. When we do this, we want to make sure all of the probes are disconnected, and then we're going to use the self-adjust function. So again, that's something we want to do on a regular basis when we use the scope. So I'd recommend if you're booting it up for the first time during the day, we're going to do that. We're going to reset it. That's going to be a good option. I'm just going to make sure my screen brightness isn't up too high because screen brightness will drain your battery a little faster. So just keep this in mind. Again, the self-adjust takes a little bit of time, probably maybe a minute and a half, something like that. But we want to make sure we do this typically on a once a day basis when we're going to use the scope. Doesn't take very long. You can see we've got the little notice in the top left corner, self-adjust is running. And again, once it's done, it's going to, that little note is going to disappear, excuse me, from the screen. So again, if you're just joining us, we're talking about the TOPDON oscilloscope and going through some real basic stuff that you need to know in order to be able to use the scope effectively on a daily basis. I will pause right now. If you have any questions, please go ahead and put them in the chat. I'm watching the chat and I will do my very best to answer your questions on the scope as we go through this. Now, I will also tell you, if you are a professional automotive technician and you are going to buy our scope, thinking about buying our scope, or perhaps you already own our scope and you would like to do some hands-on training with this, or at least have a classroom structured training, then we would encourage you specifically to watch all of the major automotive training shows in the United States. We have presented this class, an in-depth class on the scope, at one show so far this year, which was Vision in Kansas City just this past weekend. We plan to try and present this class at all of the major shows when possible. We're going to try and present it hopefully at ASTA, which is found in North Carolina and typically held in September. So if you are down in the Southeast and thinking about buying the scope or already own it and would like to take some classes on this, by all means, please, we would encourage you to come out and go to the class, assuming we can get that class scheduled. Now, I'm just looking at the comments here. I see we have a question. Okay. So we have a question about a key, which of course is not related to our webinar today, but I will attempt to answer this question while the scope is finishing up its self-adjust. So if you're trying to do any key work, specifically with Volkswagen or Audi, you do need to make sure that you have the T-Ninja box. That's the first requirement. You will also need to connect the T-Ninja box directly to the tool via USB. You're also going to need to make sure the T-Ninja box has a power supply plugged in, either via the cigarette lighter or anything like that. Okay, so we do have a question about a couple of different things on the scope. We'll answer that question as well. So I'm not going to go into the key question in real depth right now. That's definitely one that is probably better answered through a support ticket. So if you have a real specific question on something key related, if you go to topdon.us if you're a US customer, or the topdon.com website if you're a global customer, and go to the support section and make a support ticket. And if you have specifics, questions, I would recommend asking something detailed like that through a ticket, and then we will have an easy way to answer it. You also see our hotline number as well as the hours there coming up live on the chat. Now, we do have a scope relevant question. So we have a question about using the scope with an amp probe. And as a matter of fact, I have an extremely good slide or a couple of slides that I'm going to pull up specifically for this and show you that talk about how to use an amp probe on the scope. I will also talk a little bit about the attenuator and also answer the question about maximum input voltage. Now, I'm going to pull up the spec sheet here. I believe I can find this real quick. Stand by for just a quick moment here. I know the scope has a pretty high input range for voltage. Now, I will say on input range for voltage, usually what we find is what happens to scopes that get damaged is typically due to overloading of voltage under something like scoping an injector or scoping something like a solenoid, where there is a big inductive kick during the collapse of the magnetic field. So that's typically what you find as what damages scopes. It's usually not somebody scoping a base 12-volt system or anything of that nature. I'm just trying to find our page here for the scope because I know it's got the specs on there. Time out just for a moment. I'm just looking here. Now, I thought we had that on the shortcut for the specs. I'm just trying to see if I can find it now. I think it's 300 volts, but I'm going to double check. Now, naturally, I'm having problems finding the documentation, so stand by for just a second. I'll get you that answer. And that's why we do these webinars, right? Because we want to get you the information you need. I believe we have a document here. Well, maybe one of my colleagues can find that. 300. Okay, it is 300. I was pretty sure. Well, yeah, look at the scope. I keep forgetting they usually put it on the channel itself. I always forget about this. So 300 input is the maximum. Now, like I said, I don't think you're going to run across too many things that have that high of an input voltage. That's usually something that would be injector, again, collapse of the magnetic field, something like that, the inductive kick, if you will. So hopefully that is something you're not going to run across too often. And of course, like I said, it's not really something you're going to see issues with as a general statement. Now, the other question we had was a couple of different questions regarding how we use a current probe. Now we'll get to that, but I want to show you a couple other basic things you need to know before we get to that. So stand by, you're definitely going to get an answer to that, but I want to cover a couple other things you need to understand, which will affect your use of various probes. So when we're using any kind of probe, you're going to see over on the right side of the screen here, each individual channel has the ability to manipulate the parameters. So what we get in the individual channel controls is a couple of different things. So we have the ability to invert the waveform. This is something you might use if you are specifically dealing with an amp clamp, because when we're using an amp clamp, we hook it up to whatever conductor we're using, battery cable, solenoid control wire, whatever it might be. And when we get the waveform, our eyes like to see the current flow and therefore the waveform go up. If, for instance, our waveform goes down when we hook up the amp clamp, then we want to use that invert button to toggle and flip it back over. So that's something you can do live on the fly without having to go back and physically flip the amp clamp the other direction. Now, the other things you'll see here is the coupling. So DC coupling is what you're going to use for the vast majority of testing on automotive situations. AC is typically going to be used for checking like AC voltage leakage on an alternator, things like that. We also have the ability to change the probe type. So probe type, voltage is what we're going to use on the vast majority of situations. Now, it's also important to understand that what the scope physically is reading or receiving through the lead that you have connected, regardless of whether or not that is an amp clamp or that is the regular standard probe or even a pressure sensor like a pressure transducer, what's actually physically going into the scope is still voltage. What changes is if we change the probe type from voltage to current, is it simply changes what the scope displays it as. That doesn't mean it's actually getting current flow into the scope. It just changes what the scope displays that particular parameter as. So it's essentially doing a mathematical conversion. That's all that's happening when we toggle this from voltage to current. Now, again, I'm going to go in and show you a couple of slides that show you a really easy way to figure out how you can use an amp clamp effectively with the scope, regardless of which amp clamp you own. And this is a method I use because it's simple, it's fast, and it makes sense to everybody. So if you're just joining us, we are talking about the TOPDON oscilloscope and going through some of the basics here on the tool. Now, some of the other things you're going to see here when we are in this menu is we have not only these probe types, but we also have, again, after we switch from voltage to current back and forth, if we're on the voltage scale, we have our standard lead, which is the one that's currently selected in the red box. If we switch it to the second one over, that is an ignition pickup. Now you also see down on the very bottom here, we have a 2kx, 5kx, 10kx, 1kx. Now, what those physically display is voltage in essentially thousandth scales. So when we have a spark plug, for instance, we're going to be measuring through that probe a much higher amount of voltage. Now, ignition probes typically, and I believe I have a couple I can hold up for you here, if you'll stand by for just a moment. Ignition probes that we use for secondary ignition are not physically connecting directly to the voltage on the car. They're not actually being, connected between the actual the ignition coil and the scope itself. We're not directly measuring that voltage if we're doing secondary ignition, which is what you're typically going to be doing with the scope. So you're thinking, oh boy, 1,000 volts, that will wreck the scope, right? Yes, if you connected it directly, it would wreck the scope. However, secondary ignition probes are something that you will typically be connecting on the back of the coil, on the ignition wire, things like that. And so those are not going to get damaged in conjunction with doing that. So I'm going to show you a couple of different ignition probes here. If we'll just switch cameras here so you can see this. So here's a secondary ignition probe, and this is the one that I use the most frequently. Basically what we have is we have a puck, P-U-C-K, that goes on the back of the ignition coil, and then we have some little clips that hold it on, and then we plug our scope leads into these two channels here, right? So just one scope lead, you put your black in there and your red in there. Now there's a large variety of ignition leads like this, but those ignition leads all generally work in a similar way. They, again, connect to the exterior of the coil, and they pick up the waveform so that we can perform analysis on it. So again, important to understand we're not directly connecting to the voltage there. Now, you see there's a couple other settings here. And again, the only thing that's really changing here is the scope is making a calculation. So you notice when we're on the regular lead, if we look over in the top right here on the channel itself, it shows 1 volt. Now, if we go to the ignition, it defaults to 10 kV or kilovolts. Now that is a function of the setting that we have here. If we toggle these, 1kx, 5kx, etc., again, it's showing it in 1,000 volts scale. And again, that's common when you're doing ignition, is that you're going to be measuring in that scale. It's not actually changing anything about how the scope receives the voltage. It's simply changing how it represents the voltage. Now we also have some other shortcuts here. So there's a shortcut for the ignition probe wand, which you can purchase from us. And that ignition probe wand is typically used for coil on plug. The first ignition lead we have is a clip-on that you can use for clipping onto an ignition wire for vehicles that have ignition wires still. Now, I'm not 100% sure I can tell what that one last lead is, that picture that we see that's the fourth one over. I'm not 100% sure what that actually is. So I don't use that setting. Now, again, these multipliers we see here on the screen that I'm tapping, that simply changes the scale of what the measurement scale on the left of the screen shows. It's not changing what's actually physically coming into the scope. Now, we also have our bandwidth on the bottom here, and this is the one difference that you will see between hardware version 1 of the scope and hardware version 2 of the scope. So we have a full bandwidth, we have a high pass, and we have a low pass, and then we have a 20M as far as the filter goes. So if we toggle these, you can see what's happening here. Just going to go back to a standard scope lead. Basically, what these are used for is for cutting out signal noise. So if you're wondering, what does this do for me? It's going to remove signal noise. Now, the other thing you will use that can alleviate signal noise is lowering the sample rate of the scope. So again, if you're just joining us, we're talking through some of the basic navigation of the scope first so that you can get a little bit of familiarity with how we get this set up and get the waveform on the screen. If you don't have this understanding specifically of how we get the waveform on the screen, in other words, all the parameters that we are manipulating here, you are not going to be able to properly use the scope on any situation. So you can see I'm playing around with the filter here. And on this version of the hardware, we have a little more control of the filter itself. Okay, so we're going to tap out of that. We're just going to go to the 20M. So again, the only real big difference you're going to see between one hardware version and the other hardware version is this filtering on the bottom here, labeled band width. Now, I typically just leave it on the 20M. That's the range I set it to. But of course, you can play around with it depending on the signal you're working on and see how it changes the filtering of the waveform. All right, so now we will go ahead, since we're on the topic of probes and how we manipulate that basic voltage input and the conversion. If we look here, we also have a toggle. The toggle on the far right with these little pictures of the waveform, the big and the small. And as a matter of fact, you know what? I'm actually going to switch cameras here and put the max in front of you so you can see this just a little bit better. Hopefully you can see that a little better. Over here on this side of the screen, where you see where I'm pointing with my finger, this bigger and smaller waveform. Now again, the only thing that that's actually doing to the scope screen is changing how well it fits on the screen. You're not changing what it's measuring. You're not changing the data. You're simply making it fit better on the screen. So if we have all 4 channels in use, we may have to play with that button on each of the channels to make them fit on the screen together. Now that's definitely something you will have to do on, let's say, the Lite 3, since it has a smaller screen. All right, so now I'm gonna go back here and I am going to switch and try to show you my slide deck. And this is something that should make this easier for you to understand. So now you can see the slide deck. And I'm going to skip through these real quick and get to the section where we show you how to configure an amp clamp. Because that is a super common question we get. So here's an overview of a bunch of different amp clamps. There are tons and tons of amp clamps out there. We sell the Handtech ones through TOPDON. So we have the high amp clamp and the low amp clamp, and those are basically for different purposes, right? The high amp clamp is what you're going to use for anything that consumes a large amount of current. So that would be for a relative compression test. That would be one that you would, also use for big, huge electric motors or electric motors that draw a lot of current, something like perhaps a cooling fan, right? For all the smaller stuff, you're going to probably want to use a smaller amp clamp like the CC65 Handtech, or one of the other lower rated amp clamps displayed here. Again, the brand is not necessarily crucial here. It's more about what does it have for a range that is appropriate. And yes, if you use a low range amp clamp, you can actually overload it and damage it. So make sure you're not using a really low amp clamp like a 30 amp on something like relative compression or a cooling fan that pulls maybe 60 amps. You could damage your amp clamp. Now here we're going to skip here, and here is what I do to scale my amp clamp. So I get a headlight bulb or a fog light bulb that is, a 55 watt is typically going to draw somewhere around 4 amps. So I'm going to set up the headlight bulb. I'm going to plug it in across the battery of the vehicle. I'm going to place my amp clamp around either the positive or the negative of that lead going to that bulb. So as you can see in the picture here, the bulb is powered up. We've got the amp clamp around that negative cable on this one. Again, you can do negative or positive, it doesn't matter. And what we are looking for is we're going to make our settings in the scope. We're going to change it to DC coupling. We're going to change it to current. We're going to change the probe type. Only thing we need to worry about here is the multiplier. So you see the multiplier, 1x, 10x, 20x, 50x, 20x, or 100x, and then so on and so forth. We're going to look at the scale on the left side of the screen, and we are simply going to hit the multiplier until on the screen we see it read what it should read. So again, we have roughly a 55 watt headlamp bulb. That should draw somewhere between 3 and 5 amps depending on your battery voltage, which means you can simply look at the scale on the left for the channel and play around with that multiplier button until it displays roughly 3 to 5 amps. Then you know that your scope is set up properly for your specific amp clamp. Does that make sense? I'm just going to check the comments. I know we had a gentleman who was asking specifically about that. Does that make sense to you as far as how you scale the amp clamp? Now, there's also a video on scaling amp clamps on Super Mario Diagnostics that's generic. It's not specific to one amp clamp or one scope, and he does a very good job of showing this in a different way. This way is the way I use because I find this to be the easiest. You take something that you know how much current it draws, you plug it in across the battery, you place your amp clamp around either the positive or the negative for that bulb, and then you make sure that your scope is reading the right amount of amperage. The slides, I wasn't planning to distribute them in any specific way, but if you would like, these will absolutely be found in this video, which will be on YouTube, so you will be able to refer back to this video at any time you should like. Let me see if I have any way that I can export them. And here's the second one. So I believe I actually have, so this is, I'm just going to look at what number slide this is so I can see if I can export them. Stand by. So that is slide 69 and 70. Let me just see if I can export those as a PDF. I bet I can. File, download, JPEG. I'll download the other one. File, download, JPEG. And I will, if you shoot me a message through Facebook, I can send you those two slides in a JPEG format. So no big deal. Happy to do that. Because this is just the easiest way I've found to scale it. And you can see there on the slide I have, after I set it up, I've got my clamp connected here, and you can see our scale is set up. So we have the multiplier set. We have our set to the probe type, right? Probe type should show current. I've got it toggled wrong in the picture there, but it is supposed to show current. And then we simply play around with that multiplier until we see the scale is correct, and we see the minimum and maximum that we're measuring on the channel is right in the range of what that 55 watt bulb should be drawing for current. So again, hopefully that's a really simple technique you can use. And again, that should work on literally any amp clamp, no matter if we're talking about a big, huge 600 amp clamp, 600 amp clamp, or we're talking about something like a 30 amp clamp. So again, These are things that are generic in nature as far as the tips go, but they will apply to all of the different types of probes you're using. So being able to anticipate what is a normal range for a given component you're connecting to, another thing, let's say if you're using a pressure transducer, any product or probe you buy, whether we're talking about an amp clamp or a pressure transducer, those will typically have a manual that come with them that provide that conversion rate. So they should give you the information that says the output of this particular sensor, the amp clamp, the pressure sensor, is blank. And what it will say is something like the output is 100 millivolts output from this particular amp clamp equals the equivalent of 1 amp or 10 amps, something like that. So again, they should provide that information to you, but this method I've shown you here will make it a little easier if you're using a current clamp to understand what you need to do. Now, you asked another question about attenuators. Because the scope has input range of 300 volts, you don't typically need to use one. However, if you are concerned about it and you want to use one, what you want to remember about an attenuator is every attenuator has a rating or a multiplier value. What it is going to do is reduce the voltage that comes into the scope by a certain factor or multiplier. So I will see, I think I have my attenuator here with me that I can pull out and show you guys, because that is something that is worth showing you on the camera. But what it physically will do to the signal is cut it down or reduce it by a factor that will be printed on the attenuator. I'm almost certain I have one here somewhere, but I'll double check. I got most of the scope accessories out here in front of me, but of course I can't have them all on the desk, so I gotta just double check where I got that. It should be over here in this other bag. And I take these with me all over the place, so naturally we just got back from our training, so we had all of our accessories with us. So no attenuator in this bag. All right. And I do have a large variety of amp clamps myself. So I use a pretty wide variety of them, and for good reason, right? There's always a case where you need a different amp clamp, or maybe you buy one and you don't like that one and you want to try a different one. That's not too big of a deal. It's totally common for you to buy more accessories as you get better with the scope. I know for me, I've probably just keep buying scope accessories all the time because there's so many different ways you can make use of it, right? I'm coming up empty here on my attenuator. So you know what? Stand by 1 minute. I know where there is one. I'll be right back. All right, found my attenuator. So we'll get one up here on the screen so you can see. All right, going to switch cameras so you can check it out. I'm going to stop the presenting of the slide so you can see this. So here is an attenuator here. As you can see, most attenuators will, again, have a scale printed on them. See how it says attenuation 20:1. So what that's going to do is reduce your signal by that factor. So now we'll take you inside the scope so you can see what we would do if we're going to connect to, let's say, channel 1. In order to get an accurate representation in your scale on the left side of the screen, we'll go back here so you can see, the left side of the scope screen, that's where our voltage is displayed over here. In order to get an accurate representation of what we're physically measuring with the scope, what we have to do is go into our channel and we need to use the multiplier. So if we have a 20:1 attenuation, we need to use the 20x signal. This will cause the scope to properly and accurately display what the voltage is that's actually being measured. Now again, you're probably not going to use attenuators very often since the scope is rated for a high voltage range. However, I want you to know how to use it should you want to use an attenuator or need to use an attenuator. And attenuators can only do a better job of protecting your scope from damage. So by all means, I'm not discouraging you from using them. I just don't see the need to use them super often. So again, they're going to protect the scope from overloading it with voltage that is beyond the range of its tolerance. So I'm just checking to see if we have any other questions in the scope or in the chat here. Does anybody else have any questions about any of the stuff we've covered so far on the scope, or maybe things we haven't covered on the scope yet? We're looking pretty good. Now, the other parameter I do want to show you on the scope that is very important to understand. So what we've shown you so far, we've shown you how to reset it, get it back to baseline. We've shown you how to zero out the channels, which again is an adjustment you want to perform probably each time you boot the scope up and use it. And then we've also shown you the sample rate, which is referred to as depth on the screen. We have also shown you the voltage scaling and the multiplier in each of the channel settings. Now, the other thing that we need to talk about, yes, so I'll show you both versions of the scope on the min-max. The measurement stuff, I will show you both versions of that. I'm going to switch over to the other hardware in just a second. So we had a question about accessing some of the settings on version 1 of the hardware versus version 2. We don't have a ton of time left for today, but I will switch over to the other hardware just to show you because the user interface is almost identical, but the buttons are in slightly different places. And it's important to know where they're located. So the one other parameter I just want to talk about first before we do that is the time base setting. So if we look down on the very bottom of the screen, we have a time base setting. Now you have I'm going to switch over to the other camera so you can see me pointing at the screen here. So on the time-based settings, on the very bottom of the screen, you have a big button and a small button. Those basically change your time-based settings. If we tap in the very center where the number is, that allows us to change the range accordingly on the fly, right? So if I want to have, and the way that the scope will scale everything is per division. So as we look across the scope this way, there's a certain number of divisions, which you will see by the lines. And typically most scopes, it's 10 divisions across the screen. There's also divisions this way. And so what you will typically see is as we manipulate this parameter, if we change to 1 second per division, how much total time do we have on the screen, right? We have 10 seconds of time on the screen because it's 1 second per division, 10 divisions, so on and so forth. Now, the other thing you got to understand, when you change your time base down here, you also are changing your effective sample rate. Up at the very top here, the effective sample rate will change based on how much time you put on the screen. More time on the screen reduces your effective sample rate. Less time on the screen increases your effective sample rate. And that is where you may want to play around with that setting, right? So if we're saying, hey, I got a lot of signal noise, I want to cut that down, maybe we're going to toggle and slow down to a lower sample rate. Again, if you lower your sample rate too low, you may get a distorted waveform. If you raise your sample rate too high, then you may end up with too much signal noise. So just understand that that is something that will affect what you are physically seeing on the screen. Okay, so that's the other parameter I wanted to show you. Again, we're talking specifically here about the time base. So center button allows you to see all the major ranges, and then the toggle back and forth, the big waveform and the small waveform to the left and right of the number, that allows us to just kind of toggle back and forth one step on the fly. So I'm going to plug in the other hardware now just to show you what the difference is as far as the user interface. So you have an understanding that they look a little different, but the settings are 99% the same, just in different places. All right, so now we boot up the software for the other version. And if you're watching, you will notice that the buttons have just moved a little bit. Same buttons are all there. We just happen to have different locations for them. So again, doesn't materially affect the overall performance of the scope. You just need to understand that it does look different. So some of your buttons will be in different places. Now, because I used this before, I'm going to go to the settings. I'm going to go to factory reset, and I'm going to go ahead and hit OK because I want to bring the scope back to a general baseline, right? Okay, so we're back at a general baseline. We've got all our channels turned on. We're just going to switch here, put 1 second at a time on the screen. So we're back to our general basic settings here, right? Nothing is set up. We're not trying to look at anything specific yet. We're just going to show you a couple of the basics. Okay, so we've gone through time, we've gone through voltage scaling, we've gone through conversion as far as volts to amps and whatnot, and how the scope will make that calculation, how we set up our amp clamp, and also our sample rate. Those are the most crucial things you need to know in order to start using the scope effectively. And of course, we're going to do many, many more webinars on the scope because the number of different things we can do with the scope is virtually unlimited. So I hope you will continue to join us when we do these webinars because, again, we're going to always have more stuff to talk about, whether we're talking about the scope or the scan tools or anything like that. We're going to continue to have more that we can talk about, right? There's really no limit to what we can cover with this stuff. So let's talk a little bit about measurement. And again, this is going to look real similar on whether you have version 1 or version 2 of the hardware. It's essentially going to be the same operation. So what we can do here is we can go up to the menu, and when we go into menu, there is a button for measure. Now, when we set up, what the heck? That's not showing up. Oh, I think my screen froze. That's goofy. Let me toggle back and forth once. There we go. That was strange. it didn't show. Whoa. I'm getting some strange video artifacts here. Stand by. All right, I think you can see that pretty good now. So what we're looking at now is we can physically see we have different channels, right? So what we have on the different channels is I have all 4 channels turned on right now. So we have channel 1, channel 2, channel 3, channel 4. As we click each of these radio buttons, as you can see I'm doing here with the red, we can assign a measurement that we want to make on each of those individual channels. So if I want to know, let's say the amplitude of channel 1 or the minimum and the maximum, I can turn those measurements on. Now I can also turn on the high and the low or almost any of them, right? And once we turn those on, what do we get? Why is it having a meltdown? That's weird. That's strange that it's having a meltdown. I'm gonna try unplugging it, plugging it back in. the age old tip, right? Unplug it, plug it back in. Don't know why it's having an artifacting issue there. Stand by for just a second. There we go. Now it looks normal again. Or it doesn't. Well, maybe we're gonna go to the other camera for now. We should be able to do this pretty reasonably well this way. I'm gonna turn off my overhead lights so you guys can see this, or maybe tilt this a little more. Okay, so as we're looking at this, we have the ability to go to the menu. We can go into the measurement section here. And when we're in the measurement section, what we can physically see here is we can change each of the channels and then assign different measurements to each channel. And there's a pretty good list of measurements that we can use here, right? We can look at positive pulse width, like if we're looking at something that's duty cycled. We can measure the frequency, we can measure the period, we can measure amplitude, minimums, maximums, high, low, all of that stuff. RMS typically used for something like an alternator AC voltage output to make sure we don't have excessive AC voltage. So again, there's all these different things, and you can measure each channel independently. So being able to assign those measurements to independent channels is pretty awesome, right? So menu, measure, select a channel, and then assign a measurement. And you notice down here, it also shows us the colors assigned to the individual channels, and the measurements also appear specifically in the color of the channel. So pretty useful to be able to modify those and see those live on the fly, right? So hopefully that answers the question specifically about the measurement aspect of the scope. And then if you want to clear those, we just go back into measure and we hit the clear button. And now all of our measurements are cleared out. So pretty useful to be able to make that change on the fly and being able to log that information. The other thing that's really important to understand about the scope So you'll see on the very bottom right of the screen, and I'll switch back to the camera here so you can see where I'm pointing. On the very bottom right of the screen, you'll see a run button in green. It will change to stop if you freeze whatever you're looking at on the screen. Now, when you freeze it on the screen, you'll have a number of different things you can do. We can screenshot it, which of course is a super useful thing, right? Being able to send a screenshot, save a screenshot right then and there allows us to catch a waveform right on the screen, email it out directly from the tool very quickly and easily. The other thing you can do is you can integrate those screenshots into a pre, post scan, or diagnostic scan. And that is something I find incredibly useful on the tool. So I'm going to exit out of the scope software here, and I'm going to take us back to actually a section on the tool where I have reports. So I'm going to go into the history here, and I'm going to show diagnostic reports. And I have a combined report here I'm going to open. So I'm going to open it. And I'm going to switch you to the tool screen so you can see this really good. And when I open this up, watch what I can integrate in. I have scope waveforms integrated directly into the PDF report that I have captured on this car. So this was an integrated pre-scan and post-scan. As we scroll through, I'll zoom out for you so you can see this a little better. So I have the pre-scan, which shows up on the first channel on the left. I have the post-scan on the channel on the right. I'll zoom in so you can see this a little better. So post-scan, you can see I got rid of all the faults that I had. We get time and date stamps, which is super awesome, right? Great for customer communication. What else do we get here? Here's all your faults from the original scan. The pre-scan shows all at DTC. The post-scan has no DTCs. And the pre and the post-scan actually keeps the integrated saved waveforms on both the pre-scan and the post-scan. So let's say, for instance, we did, if you look at our pre-scan here and our post-scan, see we have a dynamic battery test picture built into this pre-scan. So let's say, for instance, we took this customer and said, hey, you know what? We believe you have a bad battery. Now, in this case, this was a good battery. So, don't look at the waveform and think that that's bad. That's actually good. But let's say, for instance, we had some codes, maybe some voltage threshold faults or something along those lines, or a bunch of U codes. If we did a dynamic battery test with the scope, and what you're looking at here on the screen is this purple waveform on the top. And don't mind me, I'm a little colorblind. So the top waveform on this left hand of the two waveforms you see is the battery voltage. And the bottom waveform on that left hand waveform picture is amperage. So if I, for instance, caught a bad battery with a dynamic battery test, I could take a screenshot, integrate that into the pre-scan, and then if I had a new battery installed, and this was a Volkswagen, so it would have had to have been coded to the car, but if I had a new battery installed, I could perform that dynamic battery test a second time and integrate a new scope capture into that PDF, which could show the customer the before and the after the vehicle has been fixed. Now on the right, I actually have a fuel pump waveform. And so say, for instance, we had maybe a fuel trim related fault or maybe a fuel pump related fault code. I could integrate a before and an after waveform capture from the scope into our pre or post scan. So some pretty awesome stuff that you can do with the scope and being able to integrate it actually into your diagnostic reports. I think this is a tremendous tool for being able to communicate things to your customers and really something that's just incredibly valuable as far as, when we want to show people what's broken, being able to show it with the scope is something we can show in a way that we can't do with any other tool the same way. Now, we're just about out of time, so I want to pause for a second and see, does anybody have any specific questions we have not answered that relate to the real basic functionality of the scope that we can try to address here in the last few minutes we've got left? And of course, we do have a ton of additional webinars we're going to do on the scope to try and provide as many things as possible to you as far as tools, tips, tricks, tests, all that stuff. Okay, so no specific questions. So again, what we've gone through today, we've gone through our sample rate, we've gone through our time base, we've gone through our voltage scale, and the conversions. Triggers. Yes, I'll do a quick explanation on triggers now, and then I'll plan to do one whole webinar on triggers because there's so many different ways you can actually make use of the triggers. But I'll show you how to set the trigger on this one just briefly because it is a little bit different than some other scopes you may use. Now, the first thing I want to show you with regard to triggers, just in the simplest of terms, is we need to set our time base at a low time base. So we're going to go down to 100 milliseconds. So once we go down to 100 milliseconds, we're going to see over on the right-hand side of the screen, and I'm going to point to it here so you can see this. On the right-hand side of the screen, you're going to see a trigger level appear. Okay? When we see the trigger level appear, then we're going to go up here and hit the trigger button in the menu. So the trigger button in the menu is going to allow us, just like we did with those measurements where we can select which channel we want to have the trigger set on. And we're going to say, hey, we want our trigger to be, let's say, channel 1. So we're set on channel 1. Are we looking for a DC voltage? And again, in most cases, yes, we want DC voltage, right? Whether that's through an amp clamp or through a voltage probe or a pressure, whatever it may be, remember, DC voltage is how all of those measurements come into the scope. So then we want to set which direction we want that voltage to travel before the scope starts to react and capture it. So if we want, let's say, the voltage to go up and trigger, then we set it as a rising edge trigger. If we want it to be, oh, the scope triggers and starts recording data when the voltage goes down, like in, for instance, a dynamic battery test, then we would want to say fall, right? So in this case, we're just going to start rise. And we're going to say channel 1, and we're going to tap out of the menu. So we've set our trigger. You can see our trigger. If we look here, I'll show you again with my finger. Up here in the top of the screen, you're going to see a trigger note, and it's going to change. If we tap on that trigger, it takes you to the trigger menu as a shortcut. So a couple of different ways you can get to that. But that trigger is going to show you, it's going to point up if it's a rising edge trigger. If we change it to a falling edge trigger, you're going to see the little slope change to a down symbol. So again, we're going to do rise. And then after we set rise as the target of what we want it to trigger off of, then what we do is we use the trigger level swiper on the right side of the screen. You see how I get a little line that appears? You drag that line until you have it set at a voltage level that you want the scope to react to. So let's say you want the scope to start capturing on, oh, the voltage goes up to 12 volts. We don't have to set it to 12, but you could set it, oh, well, right now at baseline, it's at 0 volts. So as soon as it deviates significantly from that, we could just say, oh, we'll set it at roughly 1 volt. So now our trigger, you see a little yellow arrow just above the yellow line. Now we have a trigger set that as soon as that voltage breaches that threshold, the scope will begin capturing data. Now, you're like, well, what if I want to have more time on the screen? Not a big deal. Once you have set your trigger, you can go back into the time base and you can change your time base to a longer time base. So you could say, oh, I'm going to do a dynamic battery test. Sounds good, not a problem. Now we're going to set our time base to a longer time base, like 1 second per division or 2 seconds per division. And the trigger is still set up and it will trigger off of that criteria. Once we've got the trigger fully set up how we want, we're going to hit the single sequence button. And that single sequence, I'll point to it on the screen here. Single sequence is down in the bottom right corner. You're going to hit that single sequence button. That single sequence button, the scope will just sit here and you'll see your run stop button change to a screen that says wait. So now the scope is not going to start capturing any data until that trigger threshold has been breached or satisfied. Once that voltage crosses over that threshold, the scope will begin capturing, and it will capture a fair amount of data on basically anything after that trigger was satisfied. It'll get a little bit before the trigger was satisfied, but it'll predominantly display the data that comes after the trigger is satisfied. Now, like I said, we'll do a webinar on triggers specifically because there's so many different ways you can use them. And I would be doing you a disservice if I did not go into triggers in detail on a full webinar. But I can tell you, those are the basics about triggers that you want to understand and how to set them up on the scope. So hopefully that answers your questions on at least the basic part of using the triggers. Um, I don't see any other questions. Any other questions on the scope from the basic setup perspective before we wrap up for today? And like I mentioned, we could literally do hours and hours and hours and hours of, if you just Google that, it is a centralized calendar that has a large number of automotive training events listed on there. And if we are going to be at a show teaching a class, such as our top down oscilloscope in depth class, you can usually find that out on that site. If, for instance, you work at a shop and you guys are thinking about buying some of the top-down oscilloscopes and you'd like to do a like an 8-hour class at the shop, reach out to us. Let us know. We do offer paid training, dedicated, devoted specifically to shops. Of course, to cover the travel and whatnot. It's not free, but we are happy to do that. Otherwise, if you have a parts distributor in your area that you have a good relationship with, maybe you buy your top-down tools through, reach out to them. Let them know you'd like to see a top-down class in your area. If you talk to your local parts distributor and get a number of shops to talk to them specifically about having maybe a top-down scopes class, that may be something we can facilitate through your automotive parts distributor. And if you don't know if your local parts guys distribute our tools, reach out to your local salesperson and ask. So again, we like doing these classes. We love being able to interact with our customers. We'd love for you to get the most value out of the tools and have the best experience possible. So that's why we do these webinars. And of course, that's why we really like to try and support training. So we are right at our time threshold for today. So we're going to go ahead and wrap up for today. Really appreciate you taking the time to come to the class. Again, if you have thoughts, you have feedback, you have requests for things that we can cover, we'll definitely keep those on a list and try to work through those as we do these webinars on a regular basis. And just want to say thank you for coming. You will find these on our YouTube channel. Typically on the YouTube channel, you do have to go to the live tab, and any of the webinars that we've done will show up in that live tab specifically. So again, if you do have questions, you want to see other webinars, reach out to us on social media. Hit us up on topdon.us if you're in the US, or topdon.com if you are in another region besides USA or Canada. And your local TopDon distributors and support staff will reach out and tell us, hey, we want to see a webinar on blank, right? So we'll do our very best to respond to those. And as always, we really appreciate you attending. Please like, share, subscribe. We appreciate all of that. And we look forward to seeing you on the next one. So as always, I'm Hawken with TopDon, and thanks again for coming to our webinar on basic setup on the scope. And of course, stay tuned because there's many, many more to come again on both the scope as well as another wide variety of our tools. See you next time.